Kaspersky Industrial CyberSecurity Essential 2024 Updates. The first feature is Oval Inventory. Let's navigate to Assets and check new tabs at the top of the screen. There are 4 tabs: Applications, Patches, Executable Files, and Users. As you can see, we have a Windows-based engineering station with active integration status. Let's check what inventory information became available for this host due to endpoint integration. The first tab lists installed applications. You can click on any detected application to get more details. Here we can see a legitimate Step 7 industrial software, as well as some suspicious Nmap application. Each tab has different sources of data. As for this tab, the origin is Oval Scanning. Moving to Patches tab, here is the list of installed Microsoft updates. It is possible to filter out all devices with the same patch. Detected executable files are listed on the next tab. Click on any file to view detailed information like vendor, version, file location, size, and hashes. It is possible to show related events or find devices which have this executable. This tab is populated with telemetry data. Let's check the last Inventory tab, which contains a list of detected users. The Details area contains comprehensive information, including users' SID, account status, and group membership. It is possible to show related events or devices which have the same user. This tab accumulates detected user records from 3 major sources: Oval Scanning, telemetry, or users detected passively from network traffic. Let's move on to the next feature: Configuration Control for Workstations and Servers. Configuration Control tab is available on Security Audit page. Click the Add button to create a new job. First step is to select devices. In our case, it is Engineering Station. Set configuration type as Windows operating system. Name the job and set processing mode to update only to acquire initial device configuration. We shall use Endpoint's local agent, but remote job execution is also available. Job configuration is complete. Now we can run it. Job status shows several states: pending, running, and completed. Let's navigate to Assets and check Configuration Control tab for our device. As you can see, there are multiple configuration components in the list which can be reviewed and set as device benchmark separately. It is possible to maximize configuration area to effectively view data in tabular format. Now we shall create a new user on our device to further detect configuration change. We need to acquire updated user list from device. Let's create another configuration control job. But this time processing mode shall be set to compare with benchmark to raise a deviation event. Benchmarks can be set for every configuration component independently. Job execution can be scheduled to effectively control configuration changes. The job is ready. Clicking Run. At this time, job status showing configuration control before transitioning to completed state. Let's check the events to observe detected deviation from configuration benchmark. As you can see, Kaspersky user was successfully detected. User SID and group membership is shown as well. Let's navigate to Assets and open our device's Details area to check updated configuration. Now on the device's Configuration Control tab, we can compare 2 acquired layers of configuration to highlight any deviations. You can store multiple archive layers of configuration for future comparison. Our next feature is PLC Configuration Control. We have a SIMATIC S7300 PLC connected to our system. PLC configuration control is performed via active polling connector, which should be configured and enabled in advance. It supports a number of polling methods for industrial devices. In case your PLC is password protected, add a secret prior to commence job configuration. Let's navigate to Configuration Control tab and add a new job. Select Target Devices. Search box can be utilized to find devices for a particular plant unit in case they were previously grouped on the network map. Select PLC for configuration type and choose a connector. Configure method according to your hardware configuration, including devices' port, rack, and slot numbers. Select a secret from the list if required. Click Save button. Name the job and select Update only for the initial configuration acquisition. And now we are ready to run the job. Let's navigate to Assets and open Devices Details area. On the Equipment tab, we can observe PLC rack with installed cards. Raw PLC logs can be downloaded as well. Each item can be clicked to view detailed information, including firmware revision. On the Configurations tab, we can observe PLC project in text format, including information about each block and its hash value. Let's navigate to Configuration Control to create a new job for benchmark comparison, but first we need to make a change to PLC running configuration. We shall delete FC35 block from online configuration via Semantic Manager. Now it's time to create a new job to detect configuration deviation from our benchmark. We shall follow the same steps, but this time processing mode should be set as Compare with Benchmark. Let's run the job. Now we can check Events page to observe detected deviation event. On the Configuration Comparison tab, we can view highlighted changes. It is possible to hide unchanged data. As you can see, block FC35 is highlighted with red, which means it was deleted from online configuration. The data can be exported to CSV or JSON format and related traffic downloaded. Let's navigate to Assets and open PLC Details. On the Configurations tab, we can compare different layers of stored configuration. It is possible to have a number of archived configurations. By default, you have last acquired and benchmark configurations. Our next feature is Cisco IOS Switches Configuration Control. On the Assets page, we can see that Cisco IE3000 switch was detected on the network. Let's navigate to Settings and ensure that we've added a secret for Cisco device. Now we can go to Configuration Control tab and create a new job to get initial device configuration. Select the Cisco switch. Set configuration type to network devices and click Next. Name the job and set processing mode to update only. Local agent is not available for network devices, thus we should select remote connection and specify device's secret and kick server or sensor, which have access to the device. Let's run the job and wait until its completion. Now we can navigate to Assets and check what configuration components were acquired from our device. As you can see, there are plenty of components which can be viewed individually. Let's check User's configuration. ARP table can serve as a good source of information about unauthorized devices in case span traffic is not available for this network device. Each component can have its own benchmark configuration. We shall set the list of previously acquired users as a benchmark configuration for this component. Now it's time to make a change to the network switch running configuration. In our example, we are connecting to Cisco switch via SSH to add a new Kaspersky user. Let's save our changes. Now we can navigate to Configuration Control tab and add a new job to trigger deviation from benchmark event. All settings should be set same as for past job execution, except for processing mode, which should be changed to compare with benchmark. Setup is complete. Let's create and run the job. The job is completed, which means the deviation event should be already on the events page. As we can see, event description shows information about recently created Kaspersky user. Let's check Configurations tab for Cisco switch. User component is highlighted and we can open it in enlarged tabular format to compare layers of configuration. Our next feature is Oval Security Audits. We will use our engineering workstation for this demonstration. The first rule set is NIST SP 853. Let's add a new job. The first step is to select required rules from the list. On the next step, we need to add our device. Let's enter job name and select to register Detected Vulnerabilities option. Polling method should be set to local agent as we have endpoint agent installed on our device. Let's create the job and click on Run button. After status changes to completed, we need to open Scan Details and click on Get Report. We are automatically redirected to Reports page, where we can see that report generation is in progress. The PDF file can be downloaded by opening Details and clicking on Export button. Check your browser's default Downloads folder to locate the file. The report contains comprehensive information on more than 200 compliance criteria, which helps to assess device against NIST Special Publication 853. The General Info page contains a summary for all scanned devices. Further pages list detected deviations and severity. NIST rule set is primarily focused on configuration compliance. Let's now scan our engineering station with ICS CERT Vulnerability Database for SCADA systems to find more information on hosts' vulnerabilities. On Select Rules step, you can select rules which are applicable only to your system. In our example, we shall run the scan with all available rules. Select Host. Let's complete the job configuration step similar as we did before and run the job. The job is complete. Let's click on Get Report and further export generated file. The report is based on ICS CERT Vulnerability Database for SCADA systems. As we can see after Summary page, Inventory Rules detected Xeomin software on host. Next section contains detected vulnerabilities including brief description and links to CVA and KL CERT-related web pages. Let's navigate to Assets and check vulnerabilities detected for our device. Each item can be clicked to view Details card You can find a list of detected vulnerabilities for your devices on the Risks page. Starting from KICS for Networks version 4.2, it is possible to scan Linux hosts to detect industrial software vulnerabilities. Let's check our center station to view audit results. As you can see, several vulnerabilities were detected for Siemens industrial software. The Risks page contains all detected vulnerabilities for our host in tabular format. Security audit configuration steps are similar to what was demonstrated earlier. Let's check the PDF report. General info page shows that 6 vulnerabilities were found. Inventory page shows detected industrial software. Further pages contain a list of vulnerabilities that we've seen before on the Risks page. This concludes our security audit feature demonstration. The next feature is Cisco Connector. For this demo, we shall use Cisco IE3000 network switch. Let's navigate to Settings and add a new connector. The type should be set as Cisco switch. We need to enter name as well as specify server's address and connector deployment node. In our case, we are using KICS server. In Detail section, we need to set up device connection settings, including valid username and password with sufficient privileges. Connector can utilize 3 types of restriction methods, which are use MAC or IP access control lists or disable Ethernet port. Do not block network devices option allows to exclude firewalls, switches, and routers. If the option is enabled, these categories of network devices are excluded from the access restriction method. Block only new devices option applies restriction method to recently detected devices only. If the option is enabled, existing devices shall not be blocked if device status will be changed to unauthorized. Let's allow Connector to block network devices and enable notifications after reboot. We can finish Connector configuration by clicking Save button. Let's navigate to Assets. For demonstration purposes, we will assume that detected engineer's laptop is a rogue device. It was connected to the industrial network switch and now can communicate with authorized devices, including Siemens PLC. Let's open Command Prompt on engineer's laptop and execute continuous ping command to the PLC. Now we can switch back to Assets and change laptop status to unauthorized to trigger access restriction method and corresponding event. As you can observe, device was blocked on Cisco switch and ping command shows request timeout messages. Now we shall change the status back to authorized to unblock the device. After a while, the ping command shows successful replies. On the Assets Events page, we can observe that all access restriction actions, including restriction removal, were successfully registered in the product. Let's move on to our next demo, which is Sigma Killchain. There are 2 Sigma rule sets available at the moment, which can be configured and enabled in Kaspersky Endpoint Agent Policy within Kaspersky Security Center. The rat detection rule set is focused on remote administration software execution detection, which is achieved by continuous monitoring of created processes, as well as by searching for application startup artifact. The Delta V rule set is focused on abnormal user or process behavior detection, as well as system component misuse for Emerson Delta V distributed control system. It is possible to add exclusions or implement additional filtering options to meet the unique configuration setup of your control system. Now let's review KICS for Networks events for attack example, which targeted DCS Workstation to see an example of Sigma rat rule and example of user configurable rule from Delta V set. We can see unauthorized communication between attacker and target hosts. First events show that user list on target host was changed. ICS hacker account was created. Next is Sigma rat event, which informs us that our admin server was started on target host. Activity Event Graph tab provides process execution chain. Details for each process and its command line attributes can be accessed by clicking items in the activity graph. In our case, our server3.exe was executed with start parameter. Let's briefly review all remaining events. IDS technology detected use of PSExec tool from network traffic. Next, unauthorized communication over SMB protocol was detected by NIC technology, followed by IDS detection of admin connection acquired from network traffic. Next is Sigma event with ADR functionality, stating that Delta V graphic file was modified. Sigma high rate of equipment control commands rule was designed to track equipment state transition events, which frequently have low priority in Delta V installations. For example, electrical pump start, stop confirmation event or valve open or close position events. The last event signals about audible alarm flood, which basically overwhelms human capabilities for proper perception and timely event reaction. In general, such situations happen during plant or unit shutdowns, but it might be an indicator of successful cyber attack. The main goal was to show how these rules can effectively help you draw a bigger picture of a cybersecurity incident, enriching available investigation data with process control system correlated insight events.